I'll just get it going now.
Okay, this is the fulcrum, this is the pivot point. The load, as you can see, or the resistance, is in between me being the force and the fulcrum. So therefore, this is a second class lever, like a wheelbarrow. So when I lift this, I can move a lot of weight. That is a second class lever because the force is furthest from the fulcrum. If I reposition myself and turn this system into a third class lever, the load is at the end and now the force is in between the fulcrum and the load or the resistance. As you can see, if I lift this, it is actually a lot harder for me to lift. Second class levers are designed to move heavy weight because the force arm is greater than the resistance arm. All third class levers have got a shorter force arm. So the force arm is from here to the fulcrum. The resistance arm is much greater. It is longer because it's at the end of the system. So a third class lever is actually more difficult to move because it has a mechanical advantage of less than 1 or a mechanical disadvantage. Throwing a ball is a third class lever. The weight is at the end, the fulcrum is my elbow, the muscle that's causing this arm to move, the force, is in between the load and the fulcrum. Force, load, fulcrum, just like this. But the advantage with a third class lever is, we've got large range of motion, which means we've got greater velocity. Greater velocity means that that ball is going to be thrown further. So here we have an image of a third class lever. The load is at the end. The force which is creating the movement, whether it's the bicep or the deltoid, is between the load and the fulcrum. This is a third class lever. As you can see, the force arm, which is the distance from the fulcrum to the force, is less than the resistance arm. So consequently, the mechanical advantage of a third class lever is less than 1. It actually has a mechanical disadvantage. It's not designed to move a lot of weight as with a second class lever. But here's the thing, in the human body, whether it's the hip, the knee, the elbow, the shoulder, what it does do is it gives you a larger range of motion. Here is an example. If we increase the length of the lever, we increase the resistance arm, but what that means is that it's got a greater distance to travel. And with the arm, because it's traveling further than this point, it must do it more quickly. So a third class lever, the advantage is that we have greater range of motion, therefore we have greater velocity, and because of the conservation of momentum principle, the momentum before release equals the momentum after release. So because momentum is mass times velocity, when we've got a faster velocity releasing that ball, we are going to have greater momentum and therefore greater distance will be achieved when we throw that projectile. So third class levers, a mechanical disadvantage or mechanical advantage of less than 1. It has a greater range of motion, therefore greater velocity. So the performance is that we get further distance achieved. We have here a drawing of a second class lever. There aren't many examples in the human body of a second class lever, but going up on the toes is one example. Here we have the fulcrum, and the force which is pulling the body up is the gastrocnemius, which is furthest from the fulcrum. The load, our line of gravity, is in between the force and the fulcrum. So what is the mechanical advantage of a second class lever? Because the force arm is greater than the resistance arm, our mechanical advantage is greater than 1.
Yep.
So that means that we can move a lot of weight or less force is required to move it because our force arm is greater than our resistance arm. So this is a human body example of a second class lever.